Hey, welcome everyone to this session today for statistics teachers. As you probably know, we have a series of 5 sessions for today and the next 4 Fridays planned. The key idea of these 5 sessions is to give faculty participants direct experience with student activities that can be used in that 101 course. So today I should introduce myself first. My name's Alan Rossman. I teach in the Department of Statistics at Cal Poly in San Luis Obispo, California. And I'm very pleased today to introduce Dr. Jennifer McNally, who teaches in the Department of Science and Mathematics at Curry College in Massachusetts. Jennifer is also the math area coordinator at Curry, and she's a specialist in mathematics education who's done a good bit of work in teaching statistics and investigating approaches to teaching statistics. She'll be leading you through an activity introducing the idea of confidence interval today. So thanks to everyone for being here on Groundhog Day, and thanks especially to Jen for leading this session. I'll be quiet now and ask her to take over.
Wonderful. Thanks so much for joining us, everybody. We are going to be working through an activity on confidence intervals, and I'm going to lay some groundwork for those of you who may not be familiar with the simulation-based inference approach to teaching introductory statistics. So we're going to do a little bit of statistical significance in order to lead up into how do we introduce the idea of confidence intervals in the IntroStat class. The context for the activity is malaria in Yemen. It's one of the freely available resources on the statistical teaching and undergraduate biology resources page. So that's nice because not only do you have access to it without it being behind a paywall, but it's also something that you can modify and attribute back to the project so that it better fits the needs of your students. For instance, Tammy, who's on this call, modified it for us to provide more space for our students to record their responses and to give a little bit more scaffolding for the language in the worksheet. So these are available for you to customize to your specific needs. So this is what we're going to be working on today. It is a short agenda about who are our introductory statistics students, what qualities do they bring to the table? What can we capitalize on in order to really reach them and build their statistics conceptual understanding? And then also, why confidence intervals and what is it about confidence intervals that we're going to value and prioritize in the learning that students do? And then, how do we use gaze aligned teaching in order to effectively meet those goals? We'll also have a debrief and question and answer at the end. But if you have questions, please pop in. You can unmute and ask at the moment. You can drop it in the chat. We'll be monitoring that in order to make sure that this session really meets your needs. And we encourage you to stay in touch, not only through email, but we have this ongoing series of workshops, and we hope to see you at more than one of them. So here we go. So I think we'll start in the chat. I do have some activities that branch off from Zoom. I tried to limit those. I'm a really good face-to-face instructor. My online skills are okay, but I always find that it's lacking the same student engagement and active learning strategies that I am able to do much more easily in the face-to-face classroom. So trying to keep you in one place so as not to confuse everybody, but I do want you to interact with these materials in similar ways that you would have your students interact with them so that you get the full experience and can know how to empathize with your students as they do something that may be a little bit out of the norm for them. So let's start with who. In the chat, I want you to give me a characteristic of the modern statistics student. For a little bit of context, I teach at Curry College, which is a college in the northeast of the country, and we draw students from our general regional area, but we especially draw students who are neurodiverse, who have attention or learning disabilities. We would estimate that our classes are comprised of about 40% of students who identify as having either a learning disability or an attention difference. So our culture is such that we support students and we really think about what their needs are. And I think that that's what draws more students to come to our college, in addition to having a nationally recognized program specific for students with language-based learning disabilities. So I see everybody. Basically, I have our students who are really top of their class. They come to Curry. They are aspiring to get into one of our highly rated nursing programs and things like that. And I also see students who really aspire to do well in college, but may have some challenges that a traditional learning environment may pose for them. So I'm interested to hear, what have you been noticing about this latest batch of students coming into our classrooms? What are their characteristics? Write maybe two or three words into the chat, and let's see if we have some common themes come up. Interesting. Nice. So I'm seeing diverse, not
Like
math
you,
loving, anxious, right? We have a lot of first gen students coming in. Maybe they aren't able to navigate the college environment the same way as we might have expected students in the past. We have a diversity in terms of majors as well, what students are hoping to get out of the statistics class. And a lot around language and how language may be a barrier for students accessing the materials, whether it's students who are English language learners or who are just disengaged because they're so engaged with their phones or technology, or who have legitimate challenges in terms of dyslexia or some other specific learning disability. Thank you. And so my approach is always to think about my learning environment in terms of universal design for learning. So what that means to me is that I'm going to prioritize and put first the things that I value. So if I really value my students developing conceptual understanding, I'm going to make sure I put the concepts first and worry or um, attend to those other things that may be ancillary to that at a later time. So I'm really going to prioritize developing understanding. I'm going to de emphasize to a degree some of the procedural or computational aspects of what the traditional statistics class may have been. All right. And universal design to me means that if I am prioritizing what I believe is most important and stripping away the barriers as much as possible, it's going to make a better learning environment for all students, no matter whether they're coming to us, as students that are typical and that we're used to, or whether they're presenting challenges either in their behavioral choices or in their neurodiversity. All right, thank you. And a key feature of my classroom is around discourse. And I think that the investigations that we can access and the simulation based approach allows us to invite discourse into our classroom a whole lot more. And so, discourse allows us to really listen to what students are saying and to assess whether their conceptions are productive or less productive, and then build on those through our teaching. So, to me, teaching is less about me prescribing the content that I'm going to present and be very careful about the ways that I present it, and more about me anticipating what students will bring to the table, the types of things that they'll say, and then how I'll respond to those utterances in order to make connections and hopefully get students to a more productive understanding of what they're doing. And I think that active learning allows us to get a lot more information from our students. And it puts more of the ownership on the instructor, not to deliver information, but to find ways to have students apprentice us and share in the authority of the statistics learning. So it's a tall order. It's a taller order when I have a group of folks on Zoom and I don't have the ability to sort of have you pair and share like I would normally do, or have you sitting in groups around the whiteboard and the flip chart that has the applets on it. But I'm hoping that through this contrived experience, you're able to see a little bit into how would you really listen for student ideas and how would you bring those to the center of discussion so that you can evaluate them together and get students to a place where they're learning something and developing statistical conceptions. So let's start with an activity. I'm going to have you jump over to a Jamboard. And the easiest way to get there, Alan, thank you for putting the link in the chat, is to go to this landing page. I put all of the links for our session into inclusivestatistics.com/CI. Make sure the C and I are lowercase if you're typing it in yourself. And you'll see a little pencil icon, and the pencil icon will bring you to a Jamboard. And I will bring that up here on my screen as well. So when you get there, it will look like this. And this is basically a whiteboard, and you can put sticky notes onto it to respond to my question. Oops, we did that one already. Oh, no, we didn't. What is important for students to learn about confidence? So to get a sticky note, you go over to the left-hand menu, and it's the fourth icon down. And when you click on it, you're able to get your own sticky note and record something about what you value in terms of students learning about confidence intervals. Oh, there's too many of us trying to access the Jamboard. Oh, bummer. Well, that was unfortunate. So what we'll do instead is we'll have you drop your comments into the chat. Like I said, I'm a much better face-to-face instructor. If you're in the Jamboard, we can see you. There's about 26 of you. If there's too many, if you're timed out, feel free to drop your thinking about this question into the chat. We'll monitor both of them. My apologies. Great. So I'm seeing some interesting comments. One is that students are exposed to these in their everyday life, and I think it's important to draw that to the surface as well. And then I'm seeing a lot about interpretation of confidence intervals, what they measure, what correct interpretations are, as well as how we can go wrong in our interpretation of confidence interval. So that's actually good information for me because I'm thankful for that. I'm not seeing, how to calculate the confidence interval as the primary thing we want students to learn. Instead, we're really thinking about what is a confidence interval? How does it serve us in terms of the way we communicate statistical information, but also what are its limitations and what should students know about that? I'm also seeing some interesting comments about how confidence intervals width can vary based on different factors involved in our study. And that all of this is about estimating the true population proportion or true population mean. Great. Thank you. Yes, and one of the hardest things I've found for students is sort of really understanding the difference between a sample and a population and how our thinking about populations is really inferred from our best guess, which is what we get with our sample. So thank you. Perfect. So where is this lesson? Let's see, from this slide. There we go. This lesson where does this lesson fit? So for us, we teach using the Introduction to Statistical Investigations curriculum. And this is chapter 4. It comes for us in about week 5 for our students because we spend a lot of time building on what is statistical significance to begin with. So the text does a good job of defining statistical inference, not just in terms of significance, but also in terms of all the different ways that we can evaluate statistical inference. So, significance is one piece, and then estimation. This is where confidence intervals comes in, but also whether our results are generalizable and to what population, as well as the limitations that we have with studies in terms of when we can define a causal relationship between our explanatory variable and our response. And so we spent 4 weeks on significance, just understanding what are we doing when we construct a hypothesis test? How do we make a chance model? What is the meaning of a p-value in order to get us to a place where we can start to touch on estimation, which is where this lesson comes in. So, to teach significance in the simulation based inference model, we really want students to develop a core understanding that the whole point of statistics is to take our sample, which is limited. It gives us limited information, but to compare that to this model that could have happened by chance alone to see whether our results are really exceptional or extraordinary. And so we do that over several weeks, building and adding layers on so that students just start with their intuition and then formalize it a little bit more so that we can get to a place where we understand what the p-value is doing for us. So if you see on this little picture, I took a picture of this chart paper that's in my office. This is how we start in our course. We start with this is an investigation where we have a dog and we're seeing whether the dog goes to an object that its owner nods at. And we check the number of times out of 10 trials the dog goes to the correct object. And in this case, the dog goes to the correct object 9 out of 10 times. And we start just by saying, wow, 9 out of 10, that's pretty good. I'd be pretty happy with that as my score on a statistics quiz, right? But is that really exceptional? Or if I had just guessed on every question on a true false test, we'll call it, is this result possible? Is it likely to have happened? And so, what these sticky notes are I give my students 10 coins, and the 10 coins relates to the 10 trials. And I tell them, okay, you have 10 coins, and I'm also giving you one sticky note. I want you to flip those 10 coins and record on the sticky note how many came up heads. And what this is simulating is if I just have a random process that I'm repeating over and over again, and looking at a trial of 10 with many repetitions, I'm seeing the picture of what is likely results and what is not likely results. So we build a dot plot with these sticky notes on chart paper in order to get a sense of what this model will look like. And we start to call that the chance model. And all the sticky notes start out yellow, but you'll see that I've swapped out the yellow ones at 9. And if I had any at 10, I would have swapped those out as well with pink and pink or red, because I want to be consistent with how I'm modeling um, what will eventually what eventually we'll start calling the p-value. So significance starts with this intuitive understanding, and then we build with a tactile simulation this chance model. What could have happened if it was just a random process repeated over and over again? If there was just guessing. And then we overlay our sample data, which is limited and small, onto this chance model to see whether our results are extraordinary or if they matched well to that chance model. All right. So in this case, we had very few sticky notes that were pink, a whole lot of sticky notes that were yellow. And then we introduced the computer simulation that can do thousands of repetitions of this process in 0 time at all, basically. And so students are able to start to translate that tactile experience into the simulation that's computer based. So I'll pause there. I just wanted to give some background for folks who may not be familiar with our approach for significance before we expanded beyond that. Is there anything that you have noticed or wondered about what we've talked about so far? You can drop it into the chat, or you can unmute and ask.
This is Jamil Carter. I do have a question about significance. I do a similar lesson also taken from Rossman and Chance, the babies, with the helper toy and the hinderer toy. But I'm just thinking about my classes. I almost never use the word significance. I mean, even in, I use the rubric when it comes to evaluating the p-value, whatever it is, very likely, or whatever, the things are. And I'm just thinking about it right now, and I don't even I don't even use the word significance. I build all the ideas about significance, but I don't actually use the word. So I
Hmm.
guess my question is, I don't know.
Mhm.
I don't even know what my question is, but I guess I need to probably tweak my material so that I make sure that I do introduce the idea of significance um, and maybe just sort of an easy, I guess maybe I'm looking for an easy definition since, yeah.
It sounds like Sophia's asking for this something similar too. How do you explain significance to students? And the way I talk about the p-value is the probability that a random event would have returned results similar to ours, right? So significance is, beyond just this intuitive understanding, like, oh wow, that's 9 out of 10, that's pretty good. How do we get to quantifying that using a p-value, and then how do we get to making a decision based on benchmarks that are out there? So p-value less than 5%, we have significant evidence to reject the null. That is sort of our entryway into it, but I also don't want students to walk away saying, oh, as soon as I get a p-value less than 5, I have something noteworthy, right? Because it's not just about significance. We also need to think about, especially later in the course, we do a whole lot with generalizability, but also causation, because students always conflate the idea that the two variables are related, so one must be causing the other. So it's nuanced. We want students to understand that there's more to it than just this one value, and there's not just one right answer, right? We have to really contextualize what we're talking about. Um, in terms of getting to this point where students understand. What is So the lady tasting tea is one of the experiments you could do, where you pour the milk first or the tea first, and see if you can tell which is different. Um, oh, interesting. Great, great job. Are there any other questions? Yeah, and that's the other thing is, as we look at what the field is doing in terms of significance, it's so much bigger than just p-value. And there's a lot of criticism that we've based many decisions solely on p-value and significance. So um, maybe significance isn't an important term to use. But I like the idea that this one judgment, where we look at our hypothesis test and make a judgment based on this p-value, isn't the only thing we consider when we talk about statistical inference. Discernible difference, yes. Thank you. All right. So the lesson itself is about malaria in Yemen. And I taught this lesson in the fall, and many of my students did not know where Yemen was. I think things would be different around now because it's much more prominent in the news because of the world events that are happening in Yemen right now. So for my students, I found that building background is really important, making sure that students have a common understanding of at least the baseline of what uh, where in the world we're talking about, what the concept is that we're talking about. So I always start with just a basic, malaria is a mosquito-borne illness that people can get. One of the symptoms that they have is that they develop a fever. Malaria is widespread in some areas of the world, mostly because protections against mosquitoes, which we would consider to be cheap and readily available, are not affordable in areas. And and keeping the spread of these diseases down is very difficult. And so we also talk about Yemen. So where is Yemen and what's happening in the world in Yemen right now? This is a major international trade route. There's a lot of civil unrest in Yemen. There's been a lot of civil wars there. There's militant groups that have been taking over and causing harm to the people who live there, but also the people who are trying to engage in international trade in these waters. So Yemen is is mostly desert on the western side, and the city that we're going to be talking about is on the eastern side of Yemen. And so, one of the problems uh, that has to do with this study is that clinics or hospitals in Yemen do not necessarily have the supplies or the equipment to do rapid testing to see specifically what disease somebody's coming in suffering from. And so this study is looking at, okay, malaria is pretty prominent in this area. Can we estimate the proportion of people who present with a fever um, at a clinic? Can we estimate the proportion of those people who actually do have a malaria diagnosis? And that would help the hospital administrators, the aid organizations to know exactly how much anti malaria medication to have on hand in order to treat the population. Okay, so that's where we're starting. The other thing I always start with my class is a social question. I want students to engage, to feel comfortable, to immediately buy in to the lesson that we're doing. So if you're able to get to the second uh, Jamboard slide or in the chat if you'd prefer, since we can all just stay right here, I asked them, okay, so you're homesick, right? What is your favorite food to eat? Or what is your favorite comfort item to have when you're homesick? We're talking about people who have a fever. When's the last time you had a fever and what made you feel better? So go ahead and drop it in the chat or put it onto my Jamboard, please. I see some soup and sleep. Tea. Oh, yes, warm foods. That's nice. Comfy blankets. Sleep and naps. Oh, this sounds wonderful. I could go for that right now, and I don't have a fever. So some of you have animals like your cat. And so I give my students a good 5 minutes just to talk at their groups. My tables are generally arranged so that 5 students are sitting together. My class size is 25 typically. And so this just gets them to talk to each other. I'm fine with them being a little bit off task from statistics. I want my classroom to be a place where they feel like they have something important to contribute. And all of you had something important to contribute. So thank you for your notes on the Jamboard or in the chat. Okay, now we get to the real work. And the real work is around the data that comes from this authentic study. And the cool thing about the STUB activities, statistical thinking in undergraduate biology, is at the bottom of the activity, it gives you a link to the research study from which the data are pulled. So you can like go and learn more about exactly what was happening in the study, but also it gives students the credence that this is real world information. And it's pretty cool that they can sort of play with the same ideas that researchers are playing with and see whether they're able to come up with something, the results that we were looking at. As I said, we take our the student-facing documents, we take the worksheets, and we really break them down, provide a lot of space for students, helps us guide through the lesson. Especially, we have many students with attention differences, and so just helps them to sort of chunk what's happening. I would never present the slide the way it is right now, but you're all adults, and I figure we can handle it this way. What happens with these activities is that you're going to see some consistent questions that are mirrored no matter what topic you're looking at. So your first question is always going to be about what is your population? What is your sample? What variable are we talking about? What is it qualitative or quantitative? So that we're able to think in the same ways that statisticians think. What am I dealing with and what are my options, right? We want students to really develop a good core schema for that. And so I want you to take a look at the lesson. Um, the lesson link is actually, thank you. It's the first link on inclusivestatistics.com/CI. I need Alan as like my right-hand guy for everything in life. Like he's just on this. I love it. And you'll see that questions 1, 2, 3, 4, and 5 are on the front page. And my students work in groups. So I usually have them read aloud to each other at their groups. And as they're reading, they're working through these questions as I circulate around the room. And so one of the common answers that I get for question number 1 is that the population is people in Yemen. And I want you to agree with that or contextualize that a little bit. So, do you agree that the population is people in Yemen, or would your answer to number 1 be different? Feel free to drop it in the chat. You can come on voice if you'd like. So I'm seeing people qualify this a little bit. So disagreeing, right? We want to be more specific. We're talking about Hodeidah City. We're looking at people with a fever. We're not talking about the entire population. We're only talking about those who are presenting with a fever. And this is a cross-sectional study. So what we're trying to do is just take basically a snapshot in time and say, this is the best information that we have right now about this place and about people who are presenting with a fever. And actually, they have to opt into the study as well. So, we have to be very careful about how well our sample is matching our population. So we definitely want to include that it's people with a fever who are in Yemen, more specifically in Hodeidah City in Yemen. And I think that would give us enough context so that our sample is really representative of the population that we're trying to provide more information about. Nice. And what is our sample? Our sample specifically is the 355 febrile patients. So I also have to describe any vocabulary words that become about. So febrile means presenting with a fever. In fact, my nursing students will be the ones that I'll point to and say, okay, so what does that mean? Just to be able to check their understanding there too. All right. And what did we record about all of those 355 febrile volunteers? So what is the variable of interest and is it quantitative or qualitative? Feel free to drop that in the chat. Right. So it is qualitative, malaria or not. More specifically, binary qualitative, categorical is another way to say it. And it's a yes or no for those. So that means that we're talking about the population proportion of people who have fever, who present with, people who have fever who end up having a malaria diagnosis in Hodeidah City, Yemen. All right. And so we're talking about symbols. And another thing that I do is I help my students to take our representational ideas and put them into abstract ideas using symbols, but also scaffolding that up along the way. So we have a poster in the classroom because I have found that students cannot necessarily read statistics the way that we can. They just get hung up on the symbols. And so having a key for them and inviting them to include this in their notes has been really helpful. Otherwise, they just gloss over the symbols as if they're not there. And then they have problems later in reading and interpreting questions that are asked of them. So Jamil, you have your question, hand raised.
Yeah, can you explain why pi is used for the population proportion? Maybe for students it's fine, but it makes me do a double take.
Um, it seems to be the convention for proportion, the the proportion parameter. It gives my students a double take because pi in geometry class meant something completely different to them. And I do raise that with them. I say, we've reused symbols and that can be confusing to you. This does not mean what you probably interpreted as 3.14, blah, blah, blah. Instead, this is really standing in for the words population proportion. Does that
Oh.
address what you were asking?
Yeah, I mean, I've just always used P, and so I didn't know if there was some reason why, people just wanted to avoid P, maybe because it's confusing with P value or something.
Yes, all of
But
those
okay,
things.
okay. Well, now I know. Okay, thank you.
Thank you. And then what we do with question 4 is really getting to the idea that um, when we've collected this data, we have one snapshot, we have one piece of data. Um, it doesn't tell us everything. And so thinking about number 4, it starts to invite the question, how can we figure out what the population proportion is if all we have is the sample statistic? So my students generally struggle with this a bit. So we do have to have an extended conversation about, does our sample statistic tell us anything? And what does it tell us? And what does it serve as when we use data in order to make an estimate of the true population proportion? All right. So as I've said, we've already done significance. We've added on the layer of the language of hypothesis testing before this point. So when we get to question number 5, I use this as an entry point into the topic that we're studying for the week, which is estimation. And we do that through something familiar to students. I don't want students to see every new topic that we address each week as something completely discrete and new from everything that they've learned before. Instead, I want them to see that we're adding layers onto our understanding of inference and that things connect together meaningfully. And it's not just all sort of like alphabet soup with all of our symbols and thoughts and ideas in a disconnected sort of array. So what we do next is we enter into our discussion about estimation by first doing something they're familiar with, which is carry out a hypothesis test. So in this case, we're saying, okay, let's just start and say, is it as likely as not that people present at this clinic with a fever and have malaria? So even that as likely as not academic language, I need to unpack for my students and say, okay, what does that mean, right? As likely as not, that means that we're going to evaluate these data against the null hypothesis of 50%, right? Are we looking at a 50% infection rate for malaria, or is it something else? All right. I'm having a hard time keeping up with the chat. Alan, will you let me know if there's anything that I miss? We can come back to these at the end too. I like putting hypothesis testing before confidence intervals, and you'll see how the approach that we use in this lesson kind of structures it in a way that builds on something familiar to students and gets them to something that's a little bit less familiar. So the first thing we do in question number 5 is set up a null and alternative hypothesis for this idea that we're going to test. Is it 50% or is it something different? All right. And finally, we actually dig into the data on the back side of the first page and we get our sample statistic. So our sample proportion for number 6, we find out that 115 of the 355 patients were confirmed to have had malaria. All right. So we're going to carry out a significance test using simulation, using the applets in order to see whether these data are exceptional or not. All right. So the Rossman-Chance applets are also linked from inclusivestatistics.com/CI. And you can carry this out yourself if you would like. But the idea is that the output that we get is going to be very similar to that sticky note chart that we made. So I always make that connection between the concrete tactile representation and uh, the representation that we get from our applet, our computer-based applet. Now, the inputs are up here, and this is something important. And I always unpack what our inputs are and what our output looks like with my students. So the inputs are, I get to decide what the probability of heads is. Where did we get 0.5 from? We get the 0.5 from our hypothesis in question number 5 that says that patients are just as likely as not to present with malaria. So just as likely as not, we decide is 50-50, 50% probability of presenting with malaria. Why does 355 look familiar? Why is there 355 in the number of tosses? Right, it is our sample size. So just as I gave you 10 coins to flip when we were looking at that dog activity with 10 trials, here, this is as if we're flipping 355 coins at once. And aren't you glad I didn't bring in 355 coins for you to flip over and over and over again? So each one of these dots represents a group of 355 tosses. And this 1,000 means that I have 1,000 of them making up this chance model down here. And I might call this the chance model because this represents the distribution of the number of successes or the number of malaria diagnoses or the number of heads in that group of 355, the same as our sample size, if it was due to random chance alone. And so I always ask my students what they notice and what they wonder. They talk a lot about the shape of our distribution, where the center is. And then you'll see that I've already overlaid as extreme as 115. And I've selected a two-sided test because I'm looking at a two-tailed hypothesis. I'm saying it's either 50% or it's something different from 50%. And you'll see that these would have lit up in red any of my 355 tosses that had more than 240 heads. And I have 0 of them. So my p-value is extremely small. It's indiscernible when I had 1,000 repetitions. So is 50%, so that's what I was testing, that's my chance model, is 50% a plausible value for the proportion of people who present with fever in Yemen who have malaria? So that's a yes or no. You can put a Y or an N in the chat. Is 50% a plausible explanation? I'm seeing a whole lot of N's. And we're judging that because we would have rejected that null hypothesis as we did a hypothesis test testing the null of 50%. Okay? So our next question is, okay, so it's not 50%. What could it be? And you'll see that our sample proportion, we notate that with p hat, our sample proportion is about 32.4%. So some of my students say, okay, it's not 50%, but another familiar proportion that I know of is 1/3, right? 33%. So the next place we go is, okay, what if instead of testing 50%, we looked at 33%? So I'm going to just pause there. The idea is that we invite a conversation about confidence intervals building on students' understanding of hypothesis test by repeatedly doing hypothesis tests until we find the outer limits of what's plausible or not. So that's the big idea. When I do that with students, I don't necessarily explain that. We just dive in and start to play with numbers a bit so that they can develop this picture of what is plausible and what is not. Right. So I'm going to pause there, make sure that I stop for any questions. I saw a lot going on in the chat a few minutes ago. Nice. I love the diversity of approaches that we have too. Like, does it matter if we do confidence interval first and then hypothesis test, or can we do it the opposite way? I love the idea that we could do it either way. Okay. So now we've changed our hypotheses, right? Now we're not looking at 50% as what we're judging. We're instead going to look at 33%. Yeah, you're right. I should probably flip that on. So the nice thing about the applet is I can switch between number of successes and proportion of successes. And I probably should have switched to proportion of successes before I took the screenshot, because then we'd be able to see this in terms of percentages, which would be a lot easier to see. The 115, yeah, and so on. So thank you, Felicia. All right. All right, so now I want you to look at the output that we got when we overlaid our sample statistic, 115 positive cases of malaria, over our chance model that was built on the assumption or the question about whether our population proportion could be 33%. I want you to write what you notice or what you wonder, what you see is different perhaps between last slide and this slide. I have not yet mentioned type 1 error. Remember I said I like to put what I value prominently first. And I know that I have more time to teach confidence intervals. It's not just this one class. So I hold on to the idea of what alpha is until a little bit later. When students start to ask me, like, what does that 95% mean when I talk about the conclusion I can draw? So thank you for that question. All right. I see a lot more red, right? And the gates got closer together. So I like that picture of what you just said there. Sorry. Yes, I probably left that out, Beth. I do say that our cutoff is our benchmark. What we typically use is 5%. So students have a familiar, that's sort of a familiar phrase as we go through, and then I refine that a little bit more as the semester goes on. All right. So you'll notice that we have our less than or equal to 115 positive cases is highlighted in red. And this 122 is like a mirror image, right? And we talk about that again a little bit later when I get into the more mechanics of how we construct the confidence interval once we get there. Where we get that 122 from. But the idea is that it's a mirror image of as extreme as 115 is, 122 is, and that's where that other number comes from. All right. So I'm seeing that a lot of people are saying they see a lot more red. In fact, 73.1% of our random repetitions came back as extreme as our sample data. And what does that tell us about the plausibility of 33%, of 1/3? Is it plausible that 1/3 of fever patients have malaria? Again, you can put a Y or an N. All right. And we're seeing that this is qualitatively different. We also have quantitatively different results, and I'm seeing a lot of yeses. So this is possible. It's possible that 1/3 of the feverish patients have malaria. So after we model a few of these, I then assign each one of my groups a different null hypothesis parameter value to try out themselves. So this is what I display on the whiteboard at the front of the class. And if you go to Jamboard slide 5, it allows you to input a p-value that you find by using the applets yourself. So you'll need to have an applet window open, but also if you wanted to input your results, have the Jamboard window open. And the way I broke it down is on the Jamboard only, unfortunately. But I basically broke it down by the first letter of your last name. So if you're on Jamboard, you can see which one you should try out. If you're not going to Jamboard, if you're just sticking here in the chat, that's okay too. You can pick any one of the parameter values to try. So any one of the top rows, and put that in to the applet as the proportion of heads, and then go from there. See how your data relate. Is it going to have very few red dots like the first one we tried where it had no red dots? Or is it going to have a whole lot of red dots like when we tried pi is equal to 1/3? And I'm actually going to switch to viewing the Jamboard so that we can see as we have people entering their results.
How many samples are we using?
So I usually do 1,000 repetitions, and the number of samples is going to be based on your sample size, and your sample size is 355.
Okay, thanks.
Sure. All right. So as the results are coming in, we're starting to understand that we've tested different hypotheses, essentially. And we're now looking at which of those hypothesis tests would result in us rejecting the null hypothesis, and which would result in us not rejecting the null hypothesis. All right, fantastic. And I'm going to go back to my slides because I filled it in. All right. And you'll see that Jamboard's a little finicky, so things are going crazy over there. But once we have everything filled in, we start talking about our decision based on each one of those two-sided p-values. And this is another place where I could have that conversation about using 5%, using 5% as our alpha, using that as our benchmark. But since it's so familiar to my students that that's what we've used by convention already, it's a conversation that I either decide to have then or decide to have later in our learning about confidence intervals. So these hypothesis values were given in this exercise. When I made my own confidence interval investigation, I did the confidence interval first to see where the boundaries would be, and then I extended a little bit beyond that, and then I based it based on how many groups I needed. So it really served my educational purpose. It wasn't really statistical in nature. These ones go up by 100th every time, so that makes it a little bit easier. So we see that we have a few probabilities that we reject, and then a whole bunch that we do not reject. and then we go back to rejecting again. So what we've done is we've ruled out the extremes on either. Oh, interesting. We've ruled out the extremes on either end. And so we start to talk about what does it mean for these green values? Well, that means that those can't be ruled out. We're not going to reject those null hypothesis values, and instead, they're plausible values. The whole idea of a confidence interval is we want to collect the range of plausible values for our population parameter. Oh gosh, I just looked at the time, Alan. I'm sorry. So I think we've achieved the goal of getting to our confidence interval, which means that we're just going to state the range of values that that are the plausible values for the true population parameter. All right. And so I talk a lot about notation and expression. And we spend time in the subsequent classes talking about this interpretation. What does the confidence interval do and what does it not do? Because students are notorious for applying sample language, applying the population parameter confidence interval language onto samples, saying that 95% of people who walk in, have malaria, or 28% of people of the sample had, like they conflate a whole bunch of things about confidence intervals and apply a population thinking down to samples. And that's what we want to avoid as much as possible. All right. So I did have a whole lot more, but this was the meat of the lesson that I do with my students. And then we talk about what are the limitations. We always do that in our work, again, to emphasize the idea that significance is only one piece of statistical inference. But then I wanted just to leave some time, and I will be here after the session ends at the top of the hour in order to answer any questions you have, but also to talk about any challenges that stand in your way to taking an approach like this with your students. So, all right. And to remind you that we do have more of these walkthroughs coming up. 4 Fun Fridays in February is how we were billing them, and one in March too. So we hope to see you at future workshops as well. I'll stick around as long as we have questions, but thank you for your time today. I hope it was valuable for you to experience this and be able to empathize with your students. There we go.
Yep. Thanks very much, Jen. We do have time for questions or comments. Thanks to everyone for coming. Please, I will send out next week the Zoom link for next week's session. Thanks for all the comments in the chat. Any questions for Jen before we wrap it up?
Hey there. Hi, Jen. Thank you so much for leading us through this. My question I put in the chat, but I think it just kind of kept going with all the flurry. So typically, how much time do you reserve for this particular activity in your classroom?
So this one activity, 75 minutes. There's a follow-up to this that gets more to the structure of what a confidence interval is, where your point estimate is, where your margin of error is, what affects the margin of error. And then we also do some like playing around with 2SD, but I didn't want to get into that today because it's so much bigger than that too. So in terms of confidence intervals, at least 3 75-minute sessions is what we do.
Thank you.
Thank you.
I had a question.
Yes.
It's about the Rossman chance on the Jamboard. My answer didn't match yours, and I'm not sure if I did something wrong or not.
Was it very far off or a little bit off? Because this is
Just a
based
little
on
bit.
simulations. Yeah, so it's based on simulations. So when I ran the simulation, it may have used a different seed than when you ran it. So
Oh, okay. Okay. I was just like, I'm not very comfortable with it, and I was just making sure because I just put 0.3633 355 and 1,000, and it was close, but I just wasn't sure what the wiggle room was.
Got it.
Okay, thank you.
Thank you.
Question came up in the chat about recordings. We have recorded this. We are recording this. I'll send out a link to where we post the recording, probably not till Monday of next week, but I will send that out. And we will record the other sessions and these fun Fridays in February. We do have 29 days in February this year. We needed 30 to make it another Friday in February, but calendar makers did not agree to my request to have 30 days in February this year. More questions for Jen? Let me ask one question that came up several times in the chat in one form or another, which is, what if you prefer to do confidence intervals before significance tests? Or what if your textbook does it that way and you don't want to do it in a different order than your textbook does? What do you advise there?
I guess I haven't thought about that because I never tried it. That's a good question. I think Soma had some ideas too, and Beth.
Well, one thought I have there is you could still use simulation to estimate the variability in the sample proportions. You could even put in the observed sample value as your null value, do 1,000 or 10,000 repetitions, and then look at the standard deviation of the resulting sample proportions. You could use that as a reasonable estimate of the standard error of p hat in that situation. And then take the sample proportion plus or minus 2 of those standard deviations, or 1.96 if you really want to be fancy. But I think most folks behind the scenes here would recommend just plus or minus 2 standard deviations at that point.
Yeah, I think that's what I was gonna say too, because it's just, I think so it came up on the Jamboard that, you have a sample statistic. That's a good place to start. How do you figure out how much variability there can be in that statistic? And generating that simulated distribution might be a good way to get introduced to the idea of variability in the statistic.
And I think that would do a much better job of looking at, the variability of the sampling distribution. Because that's one thing that I find that I have to revisit multiple times is the distribution of the samples, and students, having a hard time wrapping their head around that.
See the question that
a dummies guide for the applets. And I know we've done workshops on the applets before. I wonder if there's a recording that we can send out to some of those.
I think Beth, for many of these applets, has videos at the bottom, and she had to go to class, so she's not here anymore. But at the bottom of the screen, so I don't know, Jen, if you can
Sure.
share one of the applets on your. So I think the one proportion applet on the bottom.
Oh, how-to video. Yeah.
There you go.
Perfect. Nice.
if you ever have questions about the applets or suggestions for improving the applets, Beth is extraordinary at really valuing that input and acting on that input. You can email her directly at bchance@calpoly.edu.
Felicia, I've been using them for years and I never knew that either. So you didn't miss anything.
I will say, back to the question about the ordering in which you present confidence intervals versus hypothesis testing. I agree completely with the point Soma made in the chat earlier, which, in case you missed it, is I think it makes sense. It's a natural progression of questions to first ask, is there any difference here? Is there anything interesting going on here? And then if there is, estimate the magnitude of that difference or that effect or that phenomenon. So I think conceptually it makes sense to ask the significance testing question first, and then to follow up with the confidence interval to estimate the magnitude of the difference if you found a difference. But lots of people disagree with Soma and me. Lots of people would say the confidence interval is the more important, the more meaningful, the more informative technique. So just do the confidence interval And then if you have to make a yes/no decision about whether there's a difference, base it on the confidence interval.
And I think that this lesson does a nice job of showing the tie-in between the two
Right,
in the last
exactly.
few questions as well.
And I imagine that even if you were to just focus on confidence intervals, but if you started, like maybe start in a simple context with a one proportion and do a hypothesis test for that one single situation, and then use that to build the confidence interval off of, if they understand that process and they get to understanding the confidence interval more deeply, then later on, you don't have to keep doing the hypothesis testing. So if that's what your course requires you to do, just focus on confidence interval, doing that one extra day of hypothesis testing just to get them into that mindset might be helpful.
Right.
I see a question in the chat about whether there are different versions of the questions and activities with more or less scaffolding.
I haven't necessarily put them out publicly, but I'd be happy to share some of them. We definitely do take a close look at the questions that we ask and try to strip down as much language as possible.
It's about 7 minutes after the hour. Any final
one
questions
question.
before we stop there?
Hello, one question. Hello, one question.
Go ahead, Henry. Go ahead, Henry.
How do you set up the null hypothesis and the alternative when it's one side?
So for a one-sided, imagine we're doing the 9 out of 10 study
No, not the applet, just in symbols.
in
And why?
symbols.
Yeah, and why? Because I had a concern about different opinion about how to set up the null and alternative hypothesis in one side hypothesis. I want to
So
know some
similar
comments.
to this, just
Yeah.
with a less than sign or a greater than sign. Are you?
Yeah, one.
So with the one-sided alternative, some people, there's two different ways to present the null. You can present it as Jen has done here and leave the null with a single value,
Mhm.
or you can use the greater than or equal to inequality in the null if you have a less than alternative. My personal preference is the same as Jen's, to keep the null with a single value with a point null hypothesis. The reason I prefer that is I think it makes it easier for students to understand the idea of the p-value is the blah, 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 if the null were true. If you have a less than or equal to or a greater than or equal to in the null, then you sort of have to interpret the p-value by saying at the boundary of when the null is true.
Yeah,
But that, I don't think that's a huge.
yeah, that part there, because when we define conceptually, we say the opposite, because sometimes they say, oh, the null hypothesis, they are the opposite, the alternative, the opposite of the null. Then the students say, it's the opposite? Yes, and then why? This is greater than and the other is not less than equal. Then at some point we say it's the opposite. Then we use a word, but in another place, we write down in a different thing. The only way that is from formula statistic that we know that is satisfied. We are two iterable and we satisfy for the equal, satisfy for the other one. But this explanation is not common in the books, and in many books about why they choose equal is more internal statistical formality, because satisfy only for less than equal. But this explanation is not given in the book, and the students are confused sometimes because, oh, it's opposite, but here is no opposite how you write. This is some concern, then I wanna know if you had the same situation.
Henry, I explain it sometimes in terms of, what direction do we care about? So when we're setting the direction we care about in the alternative hypothesis, and one of the examples I use is like salmonella contamination. So when do we care that our salmonella, or that there's salmonella in our chicken? We care if it's above the, government level. We don't care below that. So we're looking for evidence that it's higher. But so we're not going to be concerned if it's equal to the limit or less than the limit. So I let them know that sometimes, even though the textbook has the equal sign, there's sort of the unwritten less than or greater than that goes along with that equality that says this is this is okay. And then the alternative is, okay, now we're going to be concerned. So I don't know if that's helpful or not.
Another question is why it's possible to introduce the student another type of hypothesis beyond the usual one. Just we have in the alternative simple and the null simple versus simple, or simple versus equal, and the other one an interval. How do you have experiences teaching that kind of another situation than real life uses for hypothesis? What experience did somebody have for that?
My short answer is I don't teach those more complicated hypotheses in a typical intro course. We do get into that in a upper level mathematical statistics course, but not in a typical introductory course.
Okay. Thank you.
You're welcome. Thanks for the questions. How about a last question before we wrap it up here? If anyone has one? Why don't I stop recording?